So now that we've defined continuity, let's start playing around with some rules for it. Throw a couple theorems in there if we have to, okay? First and foremost, so if I suppose, you guys know this is my shorthand notation for suppose that f and g are continuous. Now, it's almost trivial, these rules, all right? I know that f plus or minus g is continuous, right? I know that. I also know that f times g is continuous. And that has everything to do with the properties of limits. If I have to prove that something is continuous using limits, then the rules that govern limits are going to govern continuity as well. Okay. Number three, I know that f gths is continuous as let's see, I'm sorry, f gths is continuous if g is not equal to 0. I guess I should define this as at a point, right? At a point. All right, g is not equal to 0. And then last but not least, I know that c times f or c times g is continuous because all constant functions are continuous. All right? Now, we've already talked about what types of functions are continuous, but let's continue to sort of wrap, no pun intended, right? Let's continue to sort of wrap our brains around which functions are continuous and which are only continuous on their domains. So I know that all polynomials are continuous for all reals, are continuous for all reals. In other words, on the interval from negative infinity to infinity. All right. Rationals, root functions, trig functions, log functions. Let's see what else. Exponential. Those are actually exponentials are continuous for all reals. Exponentials. What else have we got? Oh, inverse trigs. These are all continuous at every point for all values of their domains. All right? So basically, we can do a lot of calculus. We can do a lot of mathematics with these. When we lose continuity, we run into a great deal of trouble. All right? All right. So just suffice it to say, you may say, well, wait a second, Ridley, trig functions, if I look at tangent, I mean, I know that guy goes like this, and it goes like this, and it goes like this, horribly drawn. Well, I never said that they were continuous for all reals. I said that they were continuous on their domains. So as long as we're playing ball with values of their domains, we're good as gold. All right. Now, let me give you three real quick theorems, and then we'll be done with the section. The first one is suppose, so if f is continuous at b, and the limit as x approaches a of g of x equals b, then this implies that the limit as x approaches a of the composition. Now remember, with our rules of limits, I never made any mention about composition yet. All right, so this is equal to f of b. All right, so because we now have this continuity idea, we were in trouble with compositions because we couldn't tell if I start sticking functions inside of other functions. If I take g of x and I stick it in f of x, wherever I see an x, if g of x has discontinuities or it's not defined for values, I may lose limits, and I therefore may lose continuity as well. Now, this gives us the limit basis for continuity of for compositions of functions. I apologize. I just ate lunch. I'm going into a food coma. All right. Now let's talk about continuity. If G is continuous at A and F is continuous at G of A, then f of g of x is also continuous. So in other words, as long as both of the functions that you're composing each other with are continuous at A and the function that's going in, so f has to be continuous at g of A. All right, so if g is continuous at A, and then, whoops, and then when I stick this guy in, f has to be defined. To begin with, f has to be defined, but more importantly, it's got to be continuous at g of A. Then when I compose them, I end up, with a continuous function. All right, last but not least, we're going to talk about what's called the intermediate value theorem, and this is the first of the value theorems, and you guys have already seen this. The cool thing about intermediate value theorem, it's the first of the big value theorems. There's only 3 of them: the intermediate, the extreme, and the mean value theorem. Okay, and this is also going to be referred to as the IVT. We'll see that down the road. All right, now all of the value theorems start off exactly the same way. It simply says, suppose that f of x is continuous on a closed interval from A to B. Okay? Actually, excuse me, for the intermediate value theorem, I said closed, right? I meant closed. All right? Now, all that the intermediate value theorem says, and we've seen this before. Oh man, I didn't have enough room, didn't I? Okay, so suppose f is continuous on closed interval from A to B. Okay? Now, let n be a number that lives between f of A and f of B. All right, so think about what's going on here. So let's assume, of course, that f of b is greater than f of a, just for simplicity's sake. So here comes, so f is continuous. All right, here's f of b. So here's b, and then this. Now remember, this could be flipped. I'm just assuming these inequalities for the sake of ease. And this is f of a. Now pick any number between f of a and f of b. There is guaranteed to be some value which we will call c, all right, such that f of c equals n. All right, so let's write that up real quick. If n is between f of a and f of b, then there exists, let's start getting into some notation. A backwards capital E is there exists a C on the interval from A to B such that f of c equals n. Now, this looks really smart and really math-speaky, but think about what it really says. It's not as complicated as it smells. Think about it. If you've got a function and it's continuous, it means I can't lift my pencil when I'm drawing it. If I pick some value on the function, right, or excuse me, if I pick a value between f of a and f of b on the y-axis, and I'm not allowed to lift my function as I go from f of a, slow down, Ripley, I'm not allowed to lift my pencil as I go from f of a to f of b, then I have to pass through that value. I have no choice. You saw this before in pre-calculus. You'll see it again here. It's the first of the mean or of the value theorems that you're going to play ball with. All right, thanks for your time and attention, and I'll see you in class.